Hello and welcome. My name is Untitled Chapter and I'm a solutions engineer here at Fortress Power, but you can call me Geo. And before you ask, no, I'm not wearing a lab coat. Nonetheless, as you know, Fortress Power came up with the new residential energy storage system called Avalon. Avalon system has 200 amp pass-through capability, which means that it can do whole home backup. It is outdoor rated, which means that you can install it outdoors. It can be used for grid-tied or off-grid installations, and you can interconnect either AC coupled or DC coupled solar with it. Also, you can have AC coupled and DC coupled solar working simultaneously with the Avalon system. The system is generator compatible, and it has its own integrated rapid shutdown transmitter built in. Upon your specification, it could be either Tidal or APS. But what is new about the system is that it has integrated load shedding capabilities. Namely, it has 12 load shedding circuits, and you can directly interconnect level 2 EV charger to it. It's an optional item. The Avalon system doesn't come with it, but if you want to interconnect the EV charger to the system, you interconnect it directly to it, rather than modifying the main electrical panel or even replacing it. More on that later. The system's energy capacity can be expanded to 88 kilowatt hours. So yeah, you can have three 11.4 kilowatt inverters working in parallel, or you could have three 7.6 kilowatt inverters working in parallel. Before we move on, it is important to understand that Avalon is a system. It consists of three system elements: inverter, high voltage battery, and the smart energy panel. If you remove either of these three system elements, you don't have the Avalon system anymore. The system will simply not work. So yeah, Avalon system is sold as a system. It works as the system, and also that doesn't mean that you cannot specify what type of energy capacity or power output you need. You can specify that. You can have different outputs for different sites, for different installs. You can have different energy capacities for different needs, but the concept remains the same. You have inverter, battery, and the smart energy panel. You have noticed that I mentioned high voltage battery. That is correct. This is the first high voltage battery bank that we offer for residential applications, and that is unique to our Avalon system. The reason why we decided to go with high voltage batteries is because they naturally deliver more efficiency, more efficient round trip operation, and you also can get away with thinner power cables, which means that you can save a couple of dollars on your bill of materials. But the real reason why this system is so unique and why we decided to implement this in our product lineup is the Smart Energy Panel and all the benefits that it brings. The Smart Energy Panel is the cornerstone of the Avalon system. It is an all-in-one AC combiner. It combines all types of AC inputs and perhaps outputs too, because it combines the grid and the load. It combines the EV charger and the AC coupled solar, for example. So yeah, everything AC connects to the Smart Energy Panel. And the load shedding capability is built into the Smart Energy Panel. All of this, the Avalon system with the Smart Energy Panel included as standard in the Avalon system, makes the installation easier, quicker, cleaner, and significantly cheaper. To understand how it does that, we need to answer three key questions. Why are the integrated smart load controls essential for solar energy storage system? How is Avalon Smart Energy Panel different than other load management panels? And how Avalon system helps you reducing solar storage system costs significantly. Now, before we jump into answering these questions, we first need to understand well the concept of load shedding. So consider a very conventional, not conventional, but very basic install. You have your PV, let's say it's DC coupled in this case. You have your battery and you have your grid. Then you have your main electrical panel, which has total loads of 38.4 kilowatts. And for this example, at the moment of this conversation, let's say the main electrical demands 16 kilowatts of power for the loads that you have turned on. In the middle here, we have a 10 kilowatt hybrid inverter. And just like many modern hybrid inverters, it has 200 amp pass-through capability. And let's suppose during this conversation, during this training, a grid outage occurred. You lost your 200 amp pass-through capability, and you're left with the 10 kilowatt output from the hybrid inverter. But recall, your loads are demanding 16 kilowatts. So for a little while, the inverter will treat the demand as the surge, and it's not going to disconnect immediately. But then it definitely will. Which means that on top of the grid outage, you'll have power outage because you cannot extract any power from the battery and PV because your hybrid inverter went offline because you overpowered it and because the inverter has built-in precautions that don't allow you to overpower it for extended periods of time so that the inverter is not damaged. So you're in a tricky situation. Your 10 kilowatt hybrid inverter is really not enough for the loads that you're actively using, and it's definitely not enough for the maximum possible demand of 38.4 kilowatts that your main electrical panel can impose on the power sources. So the bottleneck here is really the inverter. And not only does the inverter go offline and then it will come back and everything will be fine, but rather you're stuck in this loop that the inverter is overpowered, it goes offline, just like it went offline now, and then the inverter will turn back on only to find itself overpowered again and to go offline. So this cycle repeats unless someone goes there and turns off some of the loads. And yeah, this is a tricky situation to be in. Such system is not too useful, so to speak, because you cannot predict the power outage and turn off the extra loads. So there should be a solution to this problem, and there is. The most intuitive solution is that, well, I have one inverter, it's not enough, I'm going to have some more inverters. So in this case, I'm going to go for 4 10 kilowatt inverters, which would allow me to have 40 kilowatts of power delivery to the main electrical panel. 40 kilowatts because the maximum that the main electrical panel can demand is 38.4 is more than enough. So 40 kilowatts can satisfy the maximum demand from the main electrical panel. So if the grid outage occurs, nothing happens. Your inverters and your energy storage system as such, alongside with the PV array, manages to power the loads. But the problem is that you increase the amount of inverters, which means that you had to introduce the combiner and distribution panels, right? You had to put in the breakers in there. You had to purchase the cables. You had to interconnect all of these things. That's time, that's energy, and that's money. Yes, your system works, but at what cost? And plus, there's also one more thing. If you are quadrupling the inverter size, most likely you will have to increase the energy capacity or the size of the battery bank to comply with the minimum inverter to battery ratio. So potentially more expense there. So this is a solution, but it is not necessarily the cheapest or most affordable solution. So hence we move to solution number 2, using a critical load panel. Very common approach, very conventional. It is also an approach that has been around for a very long time. And let's see how that works. The idea here is that we have 10 kilowatt hybrid inverter that is trying to power at this moment 16 kilowatts worth of loads, but potentially 38.4 kilowatts worth of loads. Well, this main electrical panel is too big for this energy storage system slash the inverter. So what do? We split the main electrical panel. So that way we have main electrical panel on one side and critical load panel on the other side. Now, when I say split, you don't physically split it. You just rewire some of the circuits from the main electrical panel to the critical load panel in a way that the total demand from the critical load panel is such that it does not exceed the inverter capabilities. So we have 10 kilowatt inverter. That means the maximum potential demand from the critical load panel should be also 10 kilowatts, not to overpower the inverter. So in such case, when there's a grid outage, your main electrical panel does not receive any power from the grid. Your inverter makes sure to isolate itself and the energy storage system from the grid, but it continues powering the critical load panel. So whatever you have in the whatever circuits you have in the critical load panel, those are available. Loads connected to those circuits you can go ahead and use. But here as well, your system works, but you had to purchase critical load panel. You had to install the critical load panel. You had to spend a lot of time and effort rewiring the circuits so that you can move some of the circuits from the main electrical panel to your critical load panel. This is less expensive, but still quite labor-intensive approach. And it has a drawback to it compared to even solution number one. You are only backing up the loads in the critical load panel. Everything else, whatever stayed in the main electrical panel, cannot get any power during the power outage. So you are limited in what you can use. And plus, using the critical load panel does not guarantee that you're not going to need multiple inverters. Matter of fact, there is no solution that will guarantee that because energy is finite, and if your demand exceeds the energy capacity and power capacity that your energy storage system holds, you have to increase either energy storage capacity or power capacity or both. So yeah, with that, we are now introducing load shedding. So suppose this little device called load shedding element that can have two positions, either on, in which it allows the current to flow through it, or off, in which it does not allow the current to flow through it. And let's introduce this small load shedding element again on this slide. It looks like it's the quarter of the size of the main electrical panel, but usually these things are quite small. In the normal circumstance, you would have your bus bars energized in your main electrical panel, then the breaker in place. From the breaker, the so-called hot cables or hot wires are going to go to your switch or directly to the load, which has its own switch. In this case, for the load, we're using a light bulb, and for the switch, we're using a regular light switch. So if the breaker, load shedding element, or the light switch interrupts the circuit, there is no power flow to the light bulb. We cannot automate the light switch with the energy storage system. We cannot automate the breaker, but we can put in the load shedding element in between the light switch and the breaker. And we can control it based on our needs. So when the grid goes out, for example, the circuit that you're trying to load shed that contains the load shedding element will be deactivated because the load shedding element will move into the off position and will not allow the current or power to flow to the load, which means that the load is disabled and it cannot demand any power from your energy storage system. So let's introduce multiple of these load shedding elements to your regular manual electrical panel. You see here we still have the same main electrical panel. Enable circuits, those are the ones with the green. So they exceed the inverter rating, but the grid is available, so 200 amp pass-through is there, so you're just powering your main electrical panel. And the green squares, or the green rectangle as well, that means that load shedding element is in the on position, allowing the current to flow through. So everything is working, everything is fine. And then all of a sudden you lose your grid. The load shedding elements will prevent current flow to the circuits 1 to 12, right? This is the same effect as you would have with the critical load panel, because circuits, I'm sorry, not 1 to 12, but 1, 2, 3, 4, and then 8 to 12. So circuits 5, 6, 13, 14, and 15 here are enabled. With your critical load panel, the same is true. Your 5, 6, 13, 14, and 15 are enabled because they live inside the critical load panel, not the main electrical panel. So since it works with the critical load panel, the ESS itself, then it will, by the same logic and principle, it will work when you have main electrical panel with the load shedding in place. And yes, it works. But not only did you save time and energy of putting in a new critical load panel and wiring it and moving circuits and so forth, but there's also another thing. If you have enough load shedding circuits, you can have load shedding circuits dedicated to more than just the critical or more than just non-critical loads, right? So for example, here we added the load shedding circuits to 5, 13, and 15. So right now, the only circuits that will receive power no matter what are number 6 and number 14. Everything else is based on, all the other circuits are based on the position of the load shedding element, whether it's on or off. That means that we can control what combination of loads we enable in conjunction with 6 and 14, as long as we don't exceed 10 kilowatts of demand, we should be good to go. So for example, we're going to turn on 5 and 10. So right now the circuits that receive power are 14, 6, 5, and 10. As long as these circuits combined don't exceed 10 kilowatts of hybrid inverter output, we're fine. Same applies here. We have enabled 4, 15, 14, and 6. Absolutely the same logic. As long as we stay below 10 kilowatts with these circuits, we should be good to go. So that is the flexibility that I was telling you about, right? That you can have different things turned on, not at the same time, of course, but you can rotate the usage of your loads. So unlike with the critical load panel, you're not stuck with the loads or with only the loads that you have in the critical load panel, but rather you can have different loads enabled at different times. You have more flexibility in your power usage and which loads receive that power. So returning to the key questions, right? We recall that the first question was, why are the integrated smart load controls essential for solar energy storage system? Well, as I described just now, it first of all imitates the critical load panel. So with smart load controls, you can achieve the effect of a critical load panel without having a critical load panel installed. Furthermore, with smart load controls or load shedding, you may have to use less inverters to cover the same amount of load circuits as with more or bigger inverters. Now, what does this mean? You cannot have 5 kilowatt inverter covering 45 kilowatts worth of loads. Theoretically, you could, but in reality, rarely you will have the loads that you can do that with. So for example, if you have some kind of, I don't know, heating system that demands 6 kilowatts, right? That heating system alone exceeds your 5 kilowatt inverter capability. So this thing definitely gives you an edge, but it doesn't make you invincible. So when you're sizing the system, you should keep that in mind. But it's definitely better, for sure, than the critical load panel or just straight up jumping in and increasing the amount of inverters. And unlike with critical load panel, you're not limited in which loads you use. You may use more or perhaps all of them, but not simultaneously. right? So that's why the smart load controls are essential for a solar energy storage system. So at least they will allow you to have the effect of critical load panel without the critical load panel. Second benefit, well, you don't have to increase the inverter size or the quantity of the inverters right away. And number three, you're not limited in which loads you use during the grid outage, right? So that's why the integrated smart controls are essential for solar energy storage system. Question number two, how is Avalon Smart Energy Panel different than other load management panels? This is going to be a long one because we made sure that we included everything that we could possibly include to make lives of our installers, our certified installers, easier, and the end user experience as good as possible for our end users. So, on the question, how is Avalon Smart Energy Panel different than other load management panels? Here's the answer. Avalon Smart Energy Panel is not limited to load shedding capability. It's just one of its functions. Remember, I said before, it has integrated load shedding, which is integrated smart load control, but it is also an AC combiner for everything AC. Then, Avalon Smart Energy Panel doesn't require you to replace or modify the existing main electrical panel. That is right. You don't modify your main electrical panel, neither you replace it. The only thing that you do, the circuits that you want to load shed, you just pass those circuits through the smart energy panel, namely through the load shedding element of the smart energy panel. Avalon Smart Energy Panel's load shedding function is automated and can be programmed based on grid availability or precise battery percentage range. What this means is that, yes, it will react to grid outage, and yes, it will work in the configuration that you have programmed in, but you can program it in based on the battery percentage. You can tell it that, hey, you can send power to my EV charger as long as the battery percentage is above 70%, but below 70%, please disable the EV charger. Or you could tell it you can use battery for HVAC between 40 and 60%, or 40 and 100%. That would make a little more sense. But below 40% of battery, don't use the HVAC, right? So you can base your load usage on the battery percentage that you have available. Then, Avalon Smart Energy Panel has its own grid transfer switch. Yes, you don't have to worry about isolating or putting in a transfer switch or something. That is all included in the Avalon Smart Energy Panel. Then, Avalon Smart Energy Panel can combine up to 3 Avalon inverters without additional breaker boxes or combiners. That's right. If you have up to 3 inverters, and 3 inverters is the most that you can get with the Avalon system, so that would translate to 34.2 kilowatts, right? If you have 1, 2, or 3 inverters, you just wire them into the smart energy panel because it has the combiners built in, and it's very simple to combine multiple inverters in the smart energy panel. You just put in a breaker for it, really. If I was to simplify it and give you the short answer, you just put in the breakers and connect the cables to the breakers, and you're good to go. Of course, there are nuances to it, but it's that simple. You don't have to install anything extra, buy something extra for it. No, it's all there. Then, EV charger is directly connected to Avalon Smart Energy Panel. Again, no need to modify the main electrical panel. Now, that means that, for example, you have your main electrical panel full of the existing circuits, and you want your EV charger in your home. What do? You need to replace your main electrical panel, right? If it's not full, you at least need to modify the main electrical panel for it to be able to accommodate for the EV charger. Here, no, you just directly interconnect the EV charger to the smart energy panel, and on top of that, the EV charger has its own dedicated built-in load shedding element. So you use the load shedding ports that are specifically dedicated to the EV charger, which is a great thing. Then last but definitely not least, Avalon Smart Energy Panel combines and seamlessly manages power flow from different power sources such as DC coupled solar, batteries, generator, and AC coupled solar. That's right. Um, it controls what comes on and what comes off. Yes, you have your input. For example, on the generator, you can specify at what percentage it turns on, but you don't have to worry about how it balances between the different sources of energy or different sources of power. That's why, for example, remember I mentioned that you can have AC and DC coupled solar with the Avalon simultaneously, right? That's how it does it. It can balance between the different power sources, which is awesome. Um, and then it is important to understand the Smart Energy Panel and all of its features are included with the Avalon purchase. You don't pay separately for load shedding. You don't pay extra for AC combining. No, you purchase the Avalon system. The Smart Energy Panel will be there. So yeah, you should understand that there's no additional charge for the Smart Energy Panel. And we still have the third question to be answered. How Avalon system helps you reducing solar storage system costs significantly? Um, this is perhaps the most important question because yes, there are many great engineering things, but do they bring value to the table? Well, the Avalon definitely does. So to answer how Avalon system helps you reducing solar storage system cost significantly, to answer this question, I have already given you some hints, some descriptions, some training, but let's combine all that in this one slide. You can use less inverters to back up the same amount of loads, so you're saving money on the inverters. If you still have to use multiple inverters, up to 3 of them are combined by the SP without the need for additional combiner panels. So if you have to use multiple inverters, and there's no way around it, at least you don't have to buy combiners and distribution panels now, and you don't have to worry about their breakers. You don't have to worry about wiring them all together, the distances, the time, none of that. Then no need for additional critical load panel, since the built-in load shedding achieves the same effect as the critical load panel, but also provides more flexibility in load usage. Recall, with the load shedding, the very least that you can do is to achieve the effect of a critical load panel. And then, on top of that, in most cases, you can have even more circuits wired to it to achieve more flexibility in which loads get power and which ones don't, and in what conditions they don't get power. Then, EV charger connects to the SMP directly, saving you time and money by not requiring to modify or replace the existing electrical panel. I have mentioned that already, so I'm not going to waste more time on that. But just remember, the EV charger directly interconnects with the SCP. So you don't have to do anything with your main electrical panel in terms of work that you're going to perform on installing the EV charger. And then high voltage batteries allow for more efficient operation of the system. Clear enough, because you have less conversion losses. And with the set amount of power, the higher the voltage, lower the current, lower the heat losses. Very straightforward. So rather than this, you can have the Avalon system in place. So yeah, in conclusion, I want to return to the statement that I made initially, saying that the Avalon system makes the installation easier, quicker, cleaner, and significantly cheaper. And let's go over them one by one to conclude this training. So easier because everything AC connects in one place. Load shedding is there for you to use. So you don't have to worry about critical load panel and stuff like that. Quicker because you have less components. You have battery, you have inverter, and you have your SCP. Once you install these 3 components, you just have to interconnect all of these together with the grid and with the load, and that's essentially it. Cleaner, as I said, you have less components. That means you have a sleeker look, and you have uh, this very contemporary gray look that the Avalon has. So The last one, significantly cheaper. I'm not going to say anything about this anymore because I think you should be getting it by now. I have dedicated enough time to explain how it makes your system cheaper. So if you still have any questions about that, rewatch the video, contact our sales department, and they will connect you to the engineer that can help you understand the benefits. But nonetheless, for now, that's the end of this training, and I do thank you for the attention, and please don't forget to secure your energy with Fortress Power. Bye.